All right, number 35. What am I supposed to do? Reduce this, get it simple. I'm sorry that I didn't finish my homework. That's really bad. I'm a terrible person. All right, so I guess. Where did you guys start? Did you start? I don't know if I would start by making a common denominator or if I would take the cotangent and expand it.
Common denominator?
Yeah.
I did common denominator.
Let's expand this then. So this is going to be sine x over cosine squared over sine squared. And that's my fraction buffer. So if I'm going, that's better, yes. Okay. So if my first term is that, and I take the bottom and I flip it and multiply, I have the sine cubed x over cosine squared x, which makes me feel happy because the other fraction has a denominator of cosine squared. So now I have like a nice happy thing I can make one fraction. Okay, so you don't have to start this way. This is one way to start.
That's where I went wrong. I'm already there. Sorry.
So then we've got this all over cosine squared. And I'm thinking that we should factor out a sign. So if we factor out a sign and we're left with sine squared minus 1, what's sine squared x minus 1? Negative cosine, right? Because the little special thingy is sine squared plus cosine squared equals 1. So if I manipulate and I bring the 1 over, then the cosine's got to come over and it's going to be negative. So this is going to be sine x times negative cosine squared. That's probably the biggest part people would mess up. And then they cancel and I have negative sine x. Again, there are always more than, not always, but there are usually more than one way to handle.
Why negative?
Because this is negative, so if I cancel my cosines, I still have a negative 1 there. Does that make sense?
Yeah, see, I did denominator first and then I just got lost.
Yeah, and you know what? If you start to get lost, go start over. You know, I mean, that stinks, but I do it all the time. I have to start over. Because I'm down a road that's like
I
not
just love
helping me.
spending all
So
the
would
time.
you suggest expanding first always?
No.
Okay.
Because if I had done this and my denominator didn't match, then I'd have to make common denominators anyway. But I just got lucky that my denominators matched. So that was like, that's probably my clue to know I'm doing something good. Because it got easier. So 31, let's see. If we have tan x over cosecant squared. I kind of like it without all of them here.
You say that every time.
That could be what it is.
In person. I hope they watch this.
Are you
Kaden's
kidding?
not gonna
Out of all the
watch
people that
this.
left, those are the only 2 people that aren't going to watch it.
I'm just kidding. I'm just kidding. Okay, so this one, can you guys see with the glare? Is it alright? Yeah. Alright,
Yeah.
it just looks glary to me. I don't know, like, I could make a common denominator. That seems kind of hard. Yeah, let's,
See it?
I guess let's expand it and see what happens. So, that might really make our lives easier, right? So tangent sine over cosine, cosecant's 1 over sine, but it's squared. So tangent sine over cosine, and secant's 1 over cosine, but it's squared. So this isn't good. Oh, so this will still give me a common denominator, so that's good. When I flip this and multiply, oh, he's here.
Yeah, I am. Guys miss me?
We were just talking about you.
Oh, you're in DECA, go. I'm on DECA. Does anyone know what a meeting is? Nope.
Lecture
I
hall.
think it's lecture
Lecture
hall.
hall? Nice.
It's not lecture hall. We should have said the media center.
Yeah, funny. Wait, question.
Yes.
If you have like cosine and cosine squared x, is that considered?
They're not like terms.
They're not.
No.
Okay.
It'd be like x and x squared, so they can't go together. Wait. So the good news is, when I took these and expanded and I flip and multiply, I have sine cubed on top of here, cosine on the bottom. Sine x cosine squared on the top of here, cosine on the bottom. So it's good. I've got the common denominator again. And I see something really cool. When I put these together, and I have the single denominator of cosine, I'm going to skip a step. The first two would be added together, and what would I do with them?
Wait,
On that term.
I'd factor a sine x out of them.
You cancel one out.
Yeah, I think that's what I said.
Yeah, wait, can you show us how you got that?
This?
Yes.
Okay, so that I got from taking this fraction, flipping it, and turning it into multiplication. So I flipped it and multiplied, so now I have sine
Yeah.
cubed over cosine.
Can
Yeah,
you
I
show
get
that on
one.
the other one?
So this one I flipped this thing, you mean?
Yeah, how that math
So I
works.
I took this and I flipped it and multiplied. So I have sine x cosine squared x on the top, and cosine on the bottom.
You
Oh,
can't
you can't cancel them.
Well, you know what? I can,
But no.
and maybe I should have, but I didn't, which enabled me to see the common denominator.
See, I didn't do that, and that's why I got stuck.
Yeah, see, if you do cancel, then when you end up here with sine, cosine, you would then need a common denominator and get back to here anyway.
Okay.
So then-
Okay.
Wait, so then why did you multiply them?
So then, from this step, I did two things at once. I added these together so that I have a common denominator of cosine, and then I factored out a sine of the
Oh,
top.
okay.
And then what's sine squared plus cosine squared? 1. This thing's 1, so it's just sine over cosine, which is tan. Don't you get a little bit of joy out of this?
No.
When you get the answer.
If you get it right, it feels kind of good.
Yeah.
No, I sit back and I say, why did I just waste 3 minutes of my time doing that? Because if it didn't take so long, maybe. But it just takes so long.
I know. All right, 29, what should we do? 29 says use the basic identities. Okay, so all that is splitting everything into sine over cosine or whatever, and everything just cancels. So that's what 29 is. If you want me to look at yours, I'm more than happy to do so. But the answer is tan x. Everything just blah, blah, blah cancels out. 25. 25, isn't that a manipulation of getting into, like, the answer's 2, the Pythagorean triples? Are there questions on that? It was like kind of grouping things up, so that like your cosecant squared went with your whatever, cotangent squared, and then you had 1 and 1.
Are we talking 25?
Yeah.
Yeah,
I don't get it.
Okay. 25. I'm just going to distribute that negative, just so I have everything. So secant squared plus cosecant squared minus tan squared minus cotangent squared. It looks like a bunch of like garbage, but remember the Pythagorean identities, and I tell you, every time I gotta write these down. You think someday I'd memorize them, but I was time. Remember how to get them again, like quickly? I'm just in my head dividing everything by sine, and then in my head I'm dividing everything by cosine. I didn't put x's because I'm just like I'm just writing this little note to myself. Technically I should have x's with all of these. I don't want you to think there's no x's, whatever. But I just want to like in my head have it there. I'm really visual, so I kind of need to see it. So I'm looking at what I've got, and it's like, all right, if I regroup this a little bit, and I put my secant squared x minus my tangent squared x, and then I go plus cosecant squared x minus cotangent squared x. What does this equal? It's 1. If I go over here, secant squared minus tangent is 1, so that's 1. And cosecant minus cotangent is also 1. Do you see that?
Yeah. I didn't think of like distributing, so then I like made common denominators and everything.
Okay, and I just got lucky with the signs. My signs were perfect. If it was addition, like if it was secant squared plus tangent squared, I'd be stuck. That wouldn't reduce at all. If it was secant plus tangent, how would I get that to work? It wouldn't work. But I got lucky. It's secant minus tan, so if I manipulate this and bring that over, it would be 1. So you have to be careful of the signs and stuff, but it all worked out. So that's 1. Okay, and 21. This is this positive negative stuff, or even odd stuff. Sine squared of negative x plus cosine squared negative x. means? This means the sine of negative x, the whole thing squared, plus the cosine of negative x, the whole thing squared. It doesn't even matter if you remembered which was even and which was odd. But just for fun, was sine even or odd?
Odd.
Sine was odd, so this one would be negative sine x squared. And cosine was even, so it would be regular cosine squared. But it doesn't really matter, because what happens once you square it?
Becomes even.
The negative goes away anyway, because the negative squared is just going to be positive.
So it's ever sine squared or?
Wait, say it again, sorry.
So it's ever like sine squared, tan squared?
It's just a positive, yeah. So this is just sine squared x plus cosine squared x, which equals 1.
The ones that are even are sine and cosine and
Secant. Yep, those are the only ones that are even. Okay. So we didn't have any solving on the homework last night, and we just did the one yesterday. We have 2 more solving ones to do, and then just more practice. So if we do like 6 minutes of notes, and then, oh, Mitchell, who are you gonna over/under it with? Maybe Sean will make a bet for you. Nah.
It's not the same.
No. Alright, so let's just do a couple. Alright, let's see. Huh? Oh, Brenna was right yesterday, and I didn't think about it. Remember that you asked about extraneous roots? She was right. The problem was it cosine cubed over sine?
Marlena said it louder than Brenna, but Brenna said it first.
Is that what happened? I don't remember. This was the problem.
Cosine.
And we had the answers of pi over 2 and 3 pi over 2. Oh no, those were good ones. We had 0 and pi, I guess,
Yeah.
as part of the answers, and we had a whole other bunch of them. Well, 0 and pi make this 0. I don't know why I even questioned it, because it seemed obvious, but I didn't want to say the wrong thing. What's that?
So it doesn't work ever.
So those aren't going to work. So I guess you have to look at your answers and see if any of them give you a 0 in the denominator, and if they do, then you don't count them. So that example from yesterday, you got to cross out those answers. Sorry. What's that?
Those were.
Pi over 2 and 3 pi over 2 were fine, because they're not going to make sine 0. They'll make sine equal to 1. That's all fine. It's just anything that would make the denominator equal to 0 can't be included in your answers. So, sorry about that. I just wasn't thinking. All right, let's do this one.
You're smiling.
You excited? No, not at all.
Oh, this is solving.
Yeah. What's that?
What's like the one, the interval?
This one's not going to give any, so we're going to have to add like a 2 pi k thingy on it. Okay, so first of all, with solving, like yesterday, we got everything to one side, and then like tried to factor some stuff out and set everything equal to 0, whatever. This one's the same in that I'm still going to get everything to one side. But does this remind you of anything?
Factor in.
Yeah. This is like,
Swear to God.
remember those e to the x problems where we substituted a for e to the x,
So you're,
and then we had a nice like quadratic?
so you're gonna substitute sine x for x.
Exactly. I'm going to let some other variable equal the sine of x. If you don't want to do that because you see it really well, good for you. But if not, just put another variable in. It makes it so much easier. Because then if a is the sine of x, I'll have 2a squared plus a minus 1 equals 0. And I can just factor that. This is going to look a specific way. It's going to have like that something squared, and then that's something without the squared, and then no.
It was cutting off this one thing.
No, it's good. I appreciate it. So when it looks this certain way, this is what you're going to do with it. So if we factor it, 2a and a and 1 and 1, and then 2, this will be plus, and this will be a minus.
Yeah, that's right.
But the trick is to put sign back in, because a doesn't equal 1/2 and -1, or a does, but your answers are not 1/2 and -1. You can put sign back in whenever you want. I guess we can just say this. A is going to equal 1/2 and -1. But that's only a. And a is really the sign of x. So the question is just, where does sign equal 1/2 and -1? Don't get confused. I'm sorry to interrupt the kind of the question. Don't get confused if there's an x there. This might as well be theta. It just is x is the variable that's being used. That doesn't mean that all of a sudden sine is at the y value. You know what I mean? Like, don't get confused that sine is now like an x. It's not. So where is the sine equal to 1/2? Here and here. And where is it -1? Down here.
Yeah.
So just like always, we're going to give all the values within one complete rotation of the circle. So we'll have pi over 6, 5 pi over 6, 3 pi over 2, and we'll say plus 2 pi k. Because there's no restriction, this is an inverse trig. They're not telling us theta's between 0 and 2 pi. So you've got that like infinite solutions idea. Easy?
Yeah. So we have this quadratic.
All right, one more. Let's do cosine of x. I don't know, this one was in the book, so I was like, let's just look at it to make sure that, I don't know. It looks so simple, but then people will think it's hard. So, this might as well have been a question we asked earlier when we first started doing trig. Except the 0.7 would have been something like root 3 over 2, or 1/2, or 0, or 1, or root 2 over 2. Now it's 0.7. It doesn't mean that there's no answer, there's just not an easy answer. What are you going to need to solve it? A calculator. So you would need your calculator to solve this, to get the value for x. But it's an even deeper layer than this. What would x be? How could you use your calculator to find
You
it?
could just plug that in.
And what would you plug in?
That.
The inverse.
You'd push second cosine. You'd have to go
Inverse cosine of
the inverse cosine of 0.7.
Well, you wouldn't even have to do that.
Yeah.
No, you could do the numerical solve, right?
What the heck is that?
You could exact.
You guys have such fancy calculators. So you put it in inverse cosine of 0.7 or whatever, and you get an answer. And I wrote it down. What is it? It's 0.795. But the question is, do you think that's the only answer? The answer is no. Think about what the heck this
Plus
means.
2 pi k.
You're close-ish.
That's pi k.
Plus pi k might work. Let me think about it.
Yeah.
So you know the cosine looks like this?
Something like that.
Okay, here's 2 pi, so if we think about like one complete whatever. Well, we sometimes get away from,
That's probably the best graph you've drawn all year.
hey, it is pretty darn good, isn't it?
They
Just
can.
slanted.
It's because I'm not distracted by Gene. I'm just kidding. If I want to know where anything has a solution, like if I'm like from Mars and I have no idea what trig is, and I don't know why Martians don't know trig, but if they've gotten to Earth, they probably have figured out trig. But anyway,
The first thing they think about when they go to Earth, gotta figure out trig.
no, I'm just thinking like if they made it all the way from Mars to Earth without like imploding, they probably have like solved the
They
mathematical
probably don't.
Yeah, they've got
quandaries
spaceships.
of the
They don't need
universe.
trig.
What?
They don't need trig.
They've
I
got
think they
super,
did need
they've
trig
got,
to get here.
they've got
Wait,
alien
question,
powers
How
though.
would the sign the like the symbols? and
You need
the-
trig.
Wait,
They don't.
that's true.
How was
How
someone
is
like
it
how would they
different?
all invent
No,
it?
it's true.
How did someone ever come up with the idea of sine, cosine, tangent, secant?
So they're trying to model frequencies, sound frequencies, and they, I don't know why they called it this. I have no
The
idea.
guy that found sine.
But like, why do we even need it?
I don't know.
Because like what's her name said, engineering.
Right, exactly. Okay, so anyway, whenever I'm trying to solve something at all, like, just humor me for a minute. If I have like x squared equals 4, what are the answers to that? Plus or minus 2, right? One of the ways I know that is because if I graph x squared and I graph 4, I have two places where they intersect. They would intersect at the point x equals 2 and at the point x equals negative 2. And that's where those answers kind of come from. We don't,
It's like magic.
we lose the graphing connection a lot when we're solving because you're used to the algebra. Take the square root of both sides, it's a plus or minus, so it's plus minus 2. But don't forget what that means. That means if you graph both of these and you found their intersection, that would be the solutions. So go to something like this. If I graph the cosine of x, and I graph the line 0.7, what y value is this at? 1, so 0.7 is here somewhere. So if I graph the line 0.7, how many solutions do I really have even in one period? 2. So there is another one there. Like, so if I want to just slap on a 2 pi k, I'd be missing one. I'd have this one,
You could just say negative something like that.
but I'd miss this. So
Oh,
I
you could
think
take a
we
period.
could go negative 0.795.
Yeah, that would work.
It should, right? Doesn't that make sense? Because this one, it's so close to the 0, that's so close to the 2 pi. How would we get it if we wanted to add on?
You had to add the period to it, right? No.
Half.
No, add half the period, yeah.
Add half period.
Yeah, that's right,
Yeah.
because
Yeah.
halfway is in
2
between.
pi minus the
Because it should be
0.795.
going.
Wait, say that again?
2 pi minus the 0.795.
2 pi minus 0.795 would also get me there, yeah. And one way I kind of know that is if I think about the unit circle, and I think about where's the cosine 0.7, that's a positive amount, so it happens like here and it happens like here. This angle is the one we just found, 0.795 radians or whatever. So if I want to find the other one, it would be 2 pi minus 0.795, or so what is that? You can get on your calculator. What's 2 pi minus 0.795?
Alright,
Anyone have it out?
I'll get it.
See, it looks like Maximum's calculator, but he's actually just texting. Oh,
Oh.
anybody have it?
What did you want me
I want someone to do 2 pi minus 0.795. That's
to do? I
how
don't think this has a pi. Yes, it does. 2
Were you upset yet?
Yeah, I just wanted to trust on it.
pi minus what?
0.795.
0.795.
Oh, it's like
2.34.
So last minute about everything, I actually can't handle it.
2.34.
Wait, but
6,
it
5,
has
9,
to be in
2, 6,
radians or
5, 3,
degree. Does it
5,
have to be
8,
in
9,
degree or
7,
radians?
9, 3.
It wouldn't matter when we're just doing this. It's not going to make a difference. No, that can't be right.
Wait, Max.
It's 5.4. That's what I have.
What are we doing?
Yeah, it's fine.
Boom!
It had to be closer to 6, because 2 pi is like 6 point something.
More, it's just like,
Alright, now I got
Could you say plus pi k?
5.48718.530. I must
You couldn't say plus
Are
pi
we
k.
looking- are
Why? So here's
Is there
why.
anything new?
If you think
No.
about the unit circle,
we're just
and
solving.
here's
I
our
think I
here's our
forgot to
first
multiply
solution.
the first time.
Plus pi
I
would put
just
you over
pressed
here,
and
which
then
would
I
give you a
pressed pi
negative
to
x.
2x.
Not the positive x value, not the 0.7 that we're looking for would give you like a negative 0.7. It's so complicated.
And you
This
just
is-
know that 0.7's over there because you just happen to know where.
Well, I know that like if I'm looking at values of
Well, hey
cosine,
now, I'm
here's
writing on
where
that.
the cosine is 1. Here's where the cosine
Right.
is 0.
Yes.
So it's somewhere in the first quadrant between
Right.
x being
Fine.
1 and x being 0. I'm just saying it's like there. So here, like the x value is 0.7, and the y value is something. It's over closer to here. So the other place I'm looking for is down here to like be its mirror image, kind of. I can't pick over here because then the x would be negative. Anyway, this is like a far out crazy concept. I'm sorry if you already feel lost.
I'm still thinking about the Martians.
Another example, another way you can get this answer. Ah, this is great. You have a calculator in front of you. Graph it and go find this intersection point instead. Don't even worry about the 2 pi minus whatever. So find this one, you get 0.795. Find this one.
Do the settings matter when you're graphing?
It should be radians.
Alright,
Do
good.
we need to know this?
I don't know.
Come on.
But we need to know that.
You need to know that.
That.
Anyway.
That?
Yeah.
Graph cosine
I
x
thought we can't use our calculators.
equals.
If it was a calculator question, I don't know. That's kind of mean to throw something that hard on there, but
I don't even know
Whatever.
what that means.
it is what it is.
Alright, so once I graphed it then, whoa.
Then find the points of
Why
intersection,
is
but
mine
go
a
find
straight
this one.
line?
But don't find that one?
Cosine of x.
Yeah, what were you
Is that
gonna say?
what you graphed?
I graphed art cos oh.
The triangle's only going to give you the 0.795. Because like a triangle is going to have all acute angles and stuff.
Wait,
And this
I graphed
angle's
cosine of x
almost
equals-
360.
How does that work?
Just graph cosine x.
So it's not going to get it for you.
Just cosine x
Yeah,
equals
y
0.7?
No, y equals cosine x.
I need to go home.
That's how you graph something.
Yeah, I know, but how would I do it with the 0.7?
And then in
y
the
equals
y2,
cosine x minus 0.7.
in the y1, graph cosine x, and the y2, graph 0.7. And find their intersection.
Oh, whoa. Wasn't clear.
This is it. That's all we're going to do today. Then we're just going to practice.
Y2 just 0.7.
I know. I thought there'd be more. Mitchell probably won.